Hey everyone, and welcome back to the channel. Look at a railway track. It seems simple, right? Just two long, boring strips of steel holding up our world. But what if I told you that making one of these is so precise that a mistake of just a few millimeters could lead to a catastrophic disaster? And that each one is born in a furnace burning at over 1,600 degrees Celsius, hotter than flowing lava? Today, we're going into the heart of the fire to uncover the incredible science and sheer brute force behind the steel backbone of our planet, the railway track. It all begins not with shiny iron ore, but with mountains of scrap metal. Old cars, broken machinery, and discarded steel beams are the primary ingredients. This recycling process is not only efficient but also environmentally friendly. This massive pile of scrap is lifted by giant electromagnets and dumped into a colossal cauldron called an electric arc furnace. This is where things get hot. Inside the furnace, massive carbon electrodes are lowered into the scrap. An immense electrical current is passed through them, creating an arc, like a continuous bolt of lightning, that melts the steel in a roaring, fiery bath. The temperature inside can reach a staggering 1,650 degrees Celsius. But the molten steel isn't pure enough yet. It's transferred to another vessel, a ladle furnace, for refining. Here, chemists add specific alloys like carbon, manganese, and silicon. Think of it like a chef adding secret ingredients to perfect the recipe. These additions give the final rail its unique combination of strength, flexibility, and wear resistance. Once the steel recipe is perfect, the glowing, orange liquid is poured into a machine called a continuous caster. As the steel passes through the caster, it's cooled by water jets, solidifying it into a long, thick, rectangular beam called a bloom. It's still red hot, but it's finally a solid piece of metal. These blooms are then cut into shorter lengths and moved to another furnace to be reheated to the perfect temperature for shaping, around 1,200 degrees Celsius. They need to be soft and malleable for the next crucial step. This is where the magic happens. The red-hot bloom is sent through a series of massive, grooved rollers called a rolling mill. Each set of rollers is a different shape and applies thousands of tons of pressure. With each pass, the bloom is squeezed, stretched, and gradually forced into that iconic I shape we all recognize. This process is incredibly precise. The head, web, and foot of the rail must be formed to exact specifications. After rolling, the now formed rail is over 100 meters long. But you can't just let it cool down on its own. The rail is moved to a special area where it cools down slowly and evenly. This controlled cooling process is critical. It creates a fine-grained internal structure that makes the steel incredibly tough and resistant to cracking. The cooling process can cause slight bends, so the rail is then fed through a powerful straightening machine. This machine applies immense pressure to make it perfectly straight. Finally, the long rails are cut to standard lengths. But before they leave the factory, they go through intense quality control. They're scanned with ultrasound to find tiny internal flaws, their dimensions are checked with lasers, and samples are stress-tested to destruction. Only the perfect rails make it out of the factory. So, the next time you're waiting at a railway crossing and hear the rumble of an approaching train, take a moment to look at the tracks. They aren't just simple strips of metal. They are highly engineered marvels, forged in unimaginable heat and crafted with incredible precision to safely carry millions of tons across the country every single day. If you found this journey into the world of industrial manufacturing as fascinating as I did, please give this video a thumbs up and hit that subscribe button so you don't miss our next adventure. And for our question of the day, what other massive engineering marvels would you like to see us cover next? Let us know in the comments below. Thanks for watching, and we'll see you in the next one.